Hi, in this video, I will be showing you problem number 20 of chapter 2 section 5 from the practice exam. Explain why the function is discontinuous at the given number a. Select all that apply. F of x equal to x square minus 4x divided by x square minus 16 if x is not equal to 4 and f of x is equal to 1 when x equal to 4. The point A is equal to 4. So the problem is asking if to explain why the function is discontinuous at a equal to 4, at the point 4. So let's consider the function f of x, which is piecewise defined. F of x equal to x square minus 4x divided by x square minus 16 whenever x is not equal to 4, and when x equal to 4, f of x equal to 1 at x equal to 4. So if we reduce this, so you can factor the x out. So x times x minus 4 divided by x square minus 16, which can be written as x minus 4 times x plus 4. So this is the case when x is not equal to 4. So by crossing out x minus 4 factor, we get f of x equal to x divided by x plus 4 whenever x is not equal to 4. And when x equal to 4, f of x equal to 1. So the question is, why is it discontinuous at the point a equal to 4? In order for the function to be continuous at a point, then limit is x approaching a. If f of x equal to f of a, that means the function should have limit at the number a, and that value of that limit should also be equal to value of the function at a. If this condition is satisfied, then f is continuous at a. So now let's consider the left hand side at 4, the limit at x equal to 4. So limit is x approaching 4 because the function, the problem says a equal to 4. So we have to find out the discontinuity of the function at a equal to 4. So limit is x approaching 4 of f of x is limit as x approaching 4 f of x in the neighborhood of 4. Whenever it is not equal to 4, it's defined as x over x plus 4. So now you can plug and play. So x equal to 4 divided by 4 plus 4, so which is 4 over 8, which is equal to 1/2. So the limit value, namely the left hand side of this expression, the limit condition is equal to 1/2. And now we have to find out the right hand side, which is f at a. So f at a, in this case a equal to 4. So f at 4 is given to be equal to 1 by the definition. So what we see is the left hand side of this expression is equal to 1/2. Limit is x approaching 4, f of x equal to 1/2. But the value of the function at 4 equal to 1. So we notice that limit as x approaching 4 of f of x is not equal to f at 4. So the function f of x is not continuous at or discontinuous at a equal to 4 or x equal to 4. Now the question is also asking us to graph the function. So we are going to graph it. So f of x equal to x over x plus 4 after we reduce has a vertical asymptote when the denominator becomes 0 or when x equal to negative 4. Then so the vertical asymptote is x plus 4 equal to 0, which means x equal to negative 4. Horizontal asymptote is given by the leading coefficient of the numerator over leading coefficient of the denominator, which will be y equal to 1. So if we try to have we will draw the rough sketch of the graph. So horizontal asymptote is y equal to 1. And then vertical asymptote is x equal to -4. And then the graph is going to look like this. And it's going to pass through the origin. Because when you plug in x equal to 0, y equal to 0 in the function, in the original piecewise defined function, so you get the graph will pass through the origin. But notice that here when x approaches 4, y is approaching 1/2. So when x approaches 4, y is approaching 1/2, but it's not a solid point, it is a hole. So it is going to be 4 and 1/2. There is a hole at this point. This point is 4, 1/2, which is a hole. But there is a solid point though, because when x equal to 4, f at 4 is equal to 1. So there is a solid dot when x equal to 4 and at 1, y coordinate. So this is a point on the graph. 4, 1 is a point on the graph, but there is a hole at 4, 1/2. So it says that in the neighborhood of 4, the graph is approaching 1/2, but at 4, the value of the function is 1. So this clearly tells us that there is a discontinuity at the point 4. So previously we proved it algebraically. Now in the graph, it shows that there is a discontinuity at 4. Hope this video helps.